class. I'm gonna start here in just a few seconds. I've got to get everything connected to YouTube. Give me just a minute. Put it in the playlist. Okay, so now we are ready to go. First off, I wanted to go over the email I sent you guys yesterday, mainly about the changes. So today we're going to go over 4C, and then just check your schedule in Blackboard. I've updated the schedule. Every time I made a change, I've updated it. So you probably don't want to print it off per se, but just know that as we're moving along, I am updating. Some of these sections are taking a little longer to go over, and then we have things like snow and ice and stuff like that. So just make sure to check your schedule. And of course, I will update you when I make changes through email, typically through email. Okay, I did get the test graded. They are in Blackboard now, so you can go in and check those out. If you have any questions or issues or anything like that, get with me. If you think I made a mistake, please get with me. I am human. It happens every now and then. Okay, so look over those. Your rough draft, I believe, is due a week from today. Make sure I'm right by checking the schedule in Blackboard. Today's lecture, again, we're just going to go over 4C. It won't take long. I just didn't want to do a long lecture on a day that, attendance isn't mandatory or anything like that. It's just to make it. And really, I really enjoy this section. I want you to spend a little bit of time. I know it's snow day. A lot of you guys have kiddos, and you're dealing with that issue of all the kiddos being home while you're trying to learn. But I believe this chapter, or at least these few sections, are really important for just long-term life stuff. And you'll see what I'm talking about. Like yesterday or last lecture when we talked about saving, a specific amount. Like today, we're going to talk about what if we save a certain amount, over a long period of time. How much will we have? And then we'll talk about different kinds of investments. Now, guys, look, I am not a financial advisor by any means. We're just going to use the book's definition. I'm not going to give you any strategies on how to invest. It's nothing like that. It's just so we feel more comfortable when we hear these words, and we know what they mean and how they can help us long term to really kind of live independently, take our own future, or take our future in our own hands when it comes to finances. Okay, so let's keep going. So today I am going to start on 4C. I'm just going to do 4C. And the very first thing, it starts on page, I think, yes, 217, if you're following in the book. I'm on mute. No, I'm not on mute this time. And it starts off talking about the saving plan formula. So let's start there. I'm going to flick it over to the document camera. There we go. Let me turn on the lamp. I think it helps out a little bit. Oh, he's getting me through. So the savings plan formula actually is built where if you know the interest rate that you're going to get over a certain amount of time, and you know how much you're going to put back during that time in each payment, it can give you the amount that you can expect when you get done. Now, I'm going to kind of copy it straight from the book, the way the book works. But it looks like this. So we've got the amount after we've invested, and it's going to equal the payment each month. Your book uses PMT for payment. Okay. Payment each month times. And then we've got one in that's going to create a fraction actually. And then 1 plus the APR that we're going to get, which we talked about that, the annual percentage rate, over N raised to the N times Y. So N is going to be the number of payments you make per year. And so Y is number of years. That should look familiar. And then minus 1, close that set. And it's all over APR over N. Yeah. Now this is in your book. It's on page 218. I'm not going to write it again, but it's so page 218. And you can use it on the test. I'm not asking you to memorize any kind of formulas. That'd be kind of crazy. But let's use this formula. Let's say that we get out of college, and let's not do the TIA CREF. let's say we want to invest in a mutual fund, which we're going to talk about mutual funds here in a minute. But a mutual fund is just a group of stocks that you can invest in. That's a good way to think of it. And you realize with your budget, you can set aside for the payment, you can set aside $100 a month. Okay. So $100 a month. You realize you've got that wiggle room in your budget for savings. And when you look at mutual funds, I'll tell you, this is a historical average when it comes to a mutual fund. But let's say the annual percentage rate for a certain mutual fund comes out to be 9.5%. Okay, 9.5%. Now this is a little theoretical because mutual funds are investments in the stock market, so you don't get exactly an amount. It goes up and down, up and down, up and down. But over, let's say, the last 50 years, this one mutual fund has averaged 9.5%. And let's say you're 25 and you want to invest this thing again for a long amount of time. Let's say you want to invest it for, let's just say 20 years to see what happens. Okay, you're 45. That way you'll be 45 and see, maybe by then you might take it out and pay for a kid's college or something like that. And then we need the number of investments. Well, you're doing this monthly, right? Out of your monthly budget. So we're going to say N equals 12. Okay. So I think we've got everything for our formula. Now I'm going to write this as if you're writing it in your calculator if you want to do it all at once, but this one would be easier to find one at a time. Like if you found the numerator first, then found the denominator, divided those, and then multiplied it by the payment. Okay. It would be, you'll wind up making less mistakes if you work the numerator, get that number, denominator, get that number, and then divide those together and then multiply by the payment. That'll make it a lot easier in your calculator. I'll write it out as if we're not doing that, if we just want to put all on one line. So the amount would equal 100, right? That's our payment, times, you can just use parentheses. Now, I'm going to do this 1 plus our APR. Now, remember, we got to write this as a decimal, right? So it's going to be 0.095 divided by N is 12, right? Close that set. So we're done there. Now we have to raise that to the N times Y. So that's 12 times 20. Close that. So we're done there. Now we got to subtract the 1 and then close that set of parentheses. Okay, that closes off my numerator, right? So here's this, this closes off my numerator. And then I'm going to divide it by the denominator. So APR 0.095 divided by N, which we said was what, 12? Okay, so let me get my, got my phone on me. I don't have my calculator or my regular calculator. So let me pop this in there and see what we get back. Okay, here we go. 100 times, parentheses, 1 plus 0.095 divided by 12. Close that set, raise it to the 12 times 20. Bring that down, minus 1, close that set of parentheses off, and then divide it by 0.095 divided by 12. Close that set off. Now I wind up with $71,192.35. I don't know if that's right. I mean, this is me doing it by hand. This is not an example in the book, but I'm going to assume it's right. Okay. If you get something different, email me. We can work it out and see who's right or wrong. Okay. So, and then if you're wondering, well, I wonder if I would have just stuck $100 in a mattress, over the same amount of time, how much money I would have had, right? So this is with interest. This is what we would get if we got 0.095 interest each month, or actually each year, but then that's the APR. So how much if we just stuck it in a mattress or put $100 under a mattress, how much would we wind up getting? Well, if you do it without interest, you'd have 100 times 12 months times 20 years, right? So 100 times 12 times 20, you'd wind up with $24,000. So, hey, we make about almost or a little more than, more than twice. That's what 48. So almost 3 times as much. Oh, really close to 3 times as much, right? Yeah, really close to 3 times as much by putting it in the mutual fund. Now, mutual funds go up and down like the stock market, so it's not, there's a little risk involved, okay? But they do have a nice average payout over time. Okay, they have a nice average payout over time. So that's kind of neat. But this is the formula. Instead of, the last lecture in 4B, it was just one amount over time, over 30, 40 years, one principal amount. This is for a payment over amount of time. Okay, this is for a payment over an amount of time. So let's look at the retirement one. We kind of, I don't remember the exact number I used. I'm gonna say, hold on a second. Let's clear this out. I think it was like 40,000, right? Clear 40,000. I think it was, if we made 40,000 our first year, and then we multiply, we put in 3%, they put in 3%, right? So really 0.06 divided by 12. I think you wind up with $200 a month clear. So and that's again, if your amount is stagnant, right? If you wind up not getting a raise, if you make $40,000, if you're not familiar with what I'm talking about, you need to go back and watch lecture 4B. But let's say we started off at a position that made 40,000, and they give us a matching, 401k amount of 0.03. So we put in 0.03, they put in 0.03, 3%, I should say. So therefore, 40,000 times 0.06, really 6%. So 6% would be $2,400. Now that's per year. So we're going to divide that by 12, and we wind up with a payment each month into this account of $200. Okay, a payment of $200 on an account. So let's see what happens over time if we put $200 in account, and let's just say our salary stays the exact same, which it won't, right? I mean, hopefully it'll go up, might go down, but it'll go up eventually. And let's say it stays the same. So this is a little theoretical that way. So it stays the same. So we're going to put $200 in savings. And again, we're 25. Let's retire at 65 to make the number easy. So let's say 40 years. Okay. And we make the payment 12 times a year. Now let's say we get paid once a month. And then we got to think of a rate. And you know what? I'm going to Google average mutual fund rate. How about that? Average mutual fund APR. And see what we get back. All over the place. Some say 5%, some say 15%. I probably need a more specific one. Dave Ramsey says 12%. I think that's pretty high. Let's meet somewhere in the middle. Let's say Dave Ramsey says 12%, and I don't think it's that high. Let's just do a nice 10%. Why not? Keep the number easy. 10%. So do we have everything for the formula? We have the payment, we got the APR. Now remember, we're going to write this as 0.10, right? We have the number of years, and we have the number of payments each year. Yeah, we're good to go. Okay, so the amount we should expect in our retirement fund, if this is all we put in it over this time, and we got 10% on average during that time, would be, let's see here, 200. I gotta look at the formula because I do not have this memorized either. Times, now we got to do parentheses 1 plus the APR is 0.10 divided by N, which is 12, raised to the 12 times 40 now, right? 40 years because we're only 25. We're going to retire in 40 years. Oh, we have 40 years of work in front of us. That sounds lovely. And then -1, and then we're going to divide that all by the APR, which was 0.10 divided by 12. Okay, so I'm going to pop this in my calculator, see what I get. Clear, I get 200 times 1 plus 0.10 divided by 12. Close that, raise it to the 12 times 40. -1, close that, and divide by 0.10 divided by 12. That's a big number. Oh, that makes sense. It was in there for 40 years. So let's make sure. This seems a little too big. Yep. Okay, we get 1. I got to find out where to put the comma. 1264815.92. So we get $1,264,815.92. It's pretty good, right? That's a nice little nest egg. I mean, think about this. If we could get this much saved over that time based on $200, which, look, apparently Dave Ramsey thinks this is a, if you don't know who Dave Ramsey is, Google him. But Dave Ramsey thinks this is a pretty good estimate, actually a lower estimate, a less aggressive estimate than he has. But if we get that, I mean, heck, let's say we keep making 10% off just this amount, that'd be $126,000 a year we could live on, right? I mean, 10% of this is 126. You move the decimal, right? Is 126,000. So look, so we could just put back 200. This is the power of compounding. This is why I think this is so important. This is why I'm going over it. And hopefully you listen to me, okay? Again, not a financial advisor by any means. I'm not going to tell you how to invest it, but I'm going to show you the importance of compounding and what compounding can do over time. Okay. So oh yeah, well, let's see what happened if we would have put, again, that just in a mattress, right? If we would have just put it in under a mattress and let it grow, or not let it grow. So it's just, I guess, sitting on a mattress, piling up. So we got $200 times 12, because there's 12 months in a year, times 40 years. So move this up. 12 or 200 times 12 times 40, 96,000, which sounds like a lot of money, but it's a lot less than 1.2 million. Okay, 1.26 million. So just please keep that in mind when you are, especially you guys that are, I mean, anybody actually, because it doesn't take long for compound interest to kick in, but especially guys that are younger and newer in your fields, and when you start working, and I know $200 seems like a lot, and it is a lot, but it's also a huge investment in your future. Okay, and $200 a lot is going to seem like a lot at the beginning of your career, but it won't take long when $200 doesn't seem like a lot. And if you can do this in your account, a lot of times they'll do this where you don't even realize that you have it. And remember, this is only $100 a month. Your work put the other 100 in. Okay, so you just need to do this as soon as you can to get it to grow to this amount, right? The 40. I mean, let's say if we left it in there for 30 years. So I'm just going to calculate this, but let's say we can only do this for 30 years to see the difference in growth. Okay, so I'm going to do ACE of 30. So the amount after 30, we'll just say this is ACE of 40. What if we can only let it grow? Like right now, if I started working and I hadn't done this, I'm 36, so that's 30 years at 66. That'd be a normal time to retire, right? So if the only difference is 30, now I'm not going to write this out. All I'm doing is changing that number right there. So I get 200 parentheses 1 plus 0.1 divided by 12. Raise that to the 12 times 30 minus 1. Close that set. And then divide it by 0.1 divided by, set of parentheses. I'm going to graph that. I pressed the wrong button. Yeah, sorry. I'll wind up with 452,000. 096 or 7 actually. 0.58. So I'll get almost a third of it, right? By finishing, by starting 10 years later, because I'll get 10 less years of it cooking, right? Now, you can still continue. For me, I'm like, okay, well, it can still sit in the account. I can still give that amount when I get there and just kind of draw off the interest. But it's kind of neat. It's not crazy. This isn't crazy. This isn't a get rich quick scheme by any means. We're talking about 40 years of doing the right thing, which is really hard. Okay. This is not a get quick rich scheme. It's just a long-term compound interest scheme that is a perfect example for this section and for a real life math problem. Okay. Okay, so let's keep going. I think your book kind of goes the opposite way. Well, how much do we need? How much, what's the amount we need to save up to a certain amount of money, right? That's good. Okay, this is on page 220 and they change it around. So what they do is they solve for all of this. Now I'm going to do it a little different to show you where this is coming from. Now remember, hold on, just to be a little lazy, I don't have to write this out again. There's the formula, right? Now I'm going to think of this a little differently just to make it, to show you where I'm coming from and where the book's coming from, especially if you're not comfortable with algebra. So I'm going to rewrite this. I'm going to say A equals, for payment, I'm going to put P times, and now for this whole thing, I'm just going to say numerator, and this whole thing, I'm going to say denominator, okay? And the goal now is, I've got an amount that I know. I want to know what payment I need to make to get to that amount, okay? So I'm not sure what payment I need to make to get to that amount. So the way I can do that is I can just multiply by the reciprocal here. So let's use a different color. D over N. So I can multiply both sides by D over N. And what this does is it cancels because you have reciprocal fractions, and you wind up with your payment. I'm going to move it over here because it's an equal sign. It doesn't matter what way you write it. Your payment equals the amount that we want at the end, right? Times, now instead of numerator over denominator, or it's denominator over numerator, okay? That's what we're doing now. I'm going to put in all this stuff now. So therefore, remember, we called this, the A was the amount at the end times, our denominator was APR over N divided by this numerator, 1 plus APR over N raised to the NY minus 1. Okay, so that's what it looks like. So you take the amount and then you just multiply it by the reciprocal of this fraction. And then you can get, okay, what if I have an amount that I want to save up to? How much would I need to invest each month? Knowing the interest rate, right? So let's do one that's probably more, I say more realistic. Let's just say more of a set APR. Let's say you go out and you find a set APR savings account where it's, it's not based on the stock market. They're just going to give you, let's say, 3%. 3%. So let's say they're going to give you 3%, and you're trying to save up for your kid's college, right? You just had a baby and you're not sure how much to save up. And it's really, it's weird to think of how much a kid needs because so many kids are different. And there's a lot of different factors that say in there. So let's say you think that maybe it won't pay for everything. But let's say you want to save up for $40,000. Okay. I have no idea. I'm not doing this. My kid is going to go scholarship or going to be going to where I work. because we get a nice discount. Okay. So let's say N is still 12 because it's monthly. It's weird not to have N be monthly. And then Y, well, they're just born, right? So you got 18 years, okay, before they go to college. Okay. So let's see how much we need to make our payment for to hit $40,000 only at 3%, right? 3% interest isn't good, but we know it's a set interest rate. We don't have to worry about the market going up or down because they gave us this interest rate. So let's see here. So it would be, our payment would equal 40 grand. That's the amount we want at the end. Times, now I'm going to do this as fraction and then divided by numerator. So the numerator divided by the denominator. So now remember, this is going to be 0.03. So 0.03 divided by 12 divided by the denominator, 1 plus, actually, 2 sets, 1 plus 0.03 over 12 raised to the 12 times, was it 18? Because it's 18 years, minus 1. Okay, so let's say I'm going to pop this in my calculator just like this. Be careful with the parentheses, and actually you need to put parentheses around the exponent. That's probably the most common missed part where you mess it up from the calculation. 40,000 times 0.03 divided by 12 divided by big parentheses for the whole fraction. And in parentheses 1 plus 0.03 divided by 12 raised to the 12 times 18. Ooh. I put in 15 for some reason. And then minus 1, close that set of parentheses. Let's make sure I wrote this all in there right. I think I did. Yep. So my calculator is telling me I would need to save $139.89 a month. So if we save almost $140, $139.89 each month, knowing we get 3% interest for 18 years, then we'll wind up with $40,000. Okay, we'll wind up with $40,000. Again, just because I'm interested, I'm going to see what if we did this and put it in our mattress, right? If I took that $139.88 times 12 times 18, you wind up with 30,214. So you wind up with about 8 grand more or 10 grand more by doing the savings account route. And you're probably not touching it because then this one, if you get a guaranteed interest, I bet you have to make the payment so you don't pay a penalty. There's a lot of like CDs are like that, a CD, certificate of deposits like that, where they'll give you this rate, and they'll guarantee that rate, but you can't take it out because what they're doing is they're taking your money and they're investing it, making that 10 to 12% in the market. Okay, so that's a good example. Comfortable. Yeah, your book has really good real world examples in this section, and I would go over them. They're really, this is good stuff. This is stuff whenever people complain like, why don't I ever learn this in high school math? Well, yeah, I don't know. I don't get to control K-12 education. I did get to control the curriculum in this class, and this is what I chose because I've heard that so much, and I think it's so important for us to know these things. Okay, then the next topic your book goes over is total and annual return. It starts on page 223. It's not that bad. This is actually one of the kind of more basic ideas, but we just need to know how to calculate it. So let's say I'm going to use the exact example they do in the book. So it says, actually, let's define it first. The total return is the percentage change in the investment value. So let's say we started with, $3,000. Let's say we started with $3,000. And then over time, actually over a set amount of time, you need to know the amount. So over 4 years, it grew into, actually, this would be P, because that's your principal. The amount grew to 80, $8,400. I'm stealing this right from the book, guys. I'm not being creative at all. So you start with $3,000. Over 4 years, you invest it in all kinds of neat stuff, and you wind up with $8,400. Well, your total return is pretty easy to calculate. So the total return, and it's a percent, okay? The total return is just the amount you made minus the principal divided by the principal times 100%. Okay, so for us, it's going to be the amount we made, so 8,400 minus 3,000, that's 5,400, divided by the principal we started with, 3,000, and then times 100. So we wind up for a total return of I'm gonna act like I'm calculating it, but I'm just stealing it from the book. 180%. Okay, we had 180% total return over 4 years on this investment. Now, annual return is a little different, right? Because we did this over 4 years, so you have to calculate it a little bit differently. And the annual return looks like this. So for annual return, it's going to be the amount we made over our principal raised to the 1 over y minus 1. I forget about the minus 1. So the amount we made over our principal raised to the 1 minus y minus 1. And that's actually, you can multiply it by 100 too. I don't know why your book doesn't do this because it's a percent as well. So let's try it with our example. So if we wanted our example done this way, it would be, well, now the amount we made was 8,400 over 3,000 raised to the 1 over 4 minus 1. So you wind up with your book rounds to 3 decimal places, 0.9294, which is really 29.4%, right? I know what you're thinking. Hopefully you're thinking, but 29.4 times 4 is not 180. And you're right, 29.4 times 4 is 117. But this actually gives you the rate as if you were compounding on the compound interest, okay? So it's the compounded interest rate. It's not the basic rate, okay? It's not your basic rate of return. That's why it's like that. Okay. So after that, your book, and the last part of this section, actually, let me come back to the home screen. Getting cold. Put my favorite hat on. Not my favorite hat, but it's cold. I'm conserving energy at my house because they told us to on the internet. And the rest of this section, I want you to read. It goes over different types of investments. And it goes over 3. Yes, stock, bonds, and cash. And then it goes over historical returns, financial data, what each one of those means, even the current yield of a bond, things of that nature. So I want you to go over it. And then if you need help or if you're not understanding what's going on in that last part, email me. If you're not understanding what's going on in the first part, email me. Okay. But read through that. And if you have the last part of 4C, it's more about definitions than, calculations. So read through that. If it's not making sense, let me know. Let me make sure I'm on the right track here. Hold on, give me 1 second. Getting into your schedule. Yeah, so for homework, I want you to do, that's a lot of homework. This is one of the other reasons why I broke it up. It's 1 through, this is not right for 4C because there are not 113 questions. So I'll change that, but it's 1 through one through 75 odd. So 1 through 75 odd on section 4C. I will go in and change that in your schedule. Okay. Enjoy the snow days. Have a great day. I will see you all hopefully in class on Monday. I'll see your faces again.